All right, this section we're going to study simple harmonic motion. Now, we're not going to study the combining waves or damped motion. Damped motion or the combining waves. That's not, it might be part of the homework, but it's not going to be on the exam. Okay? So here's the formula for simple harmonic motion. D is the displacement, A cosine of omega t. The other one would be the displacement, A times sine of omega t. And the frequency be F equal omega over 2 pi, where omega has to be greater than 0. Now, what is this damped motion? Let's say if you take a ring and if you stretch it and if you let it go, then what happens? It compresses and then it expands again. And it oscillates back and forth, back and forth. This is the simple harmonic motion. We're not doing crazy harmonic motion. And this motion looks like sine or cosine. Now, if it starts at the resting position, we call it sine. But if you stretch it or if you press it and then let it go, then the simple harmonic motion is going to be cosine. So let me type this in. Okay, let's do it this way. Let's make this. And then one side, let's make that 24. All right. What the? All right, there you go. Let me make it bigger also. Suppose that an object attached to a coil spring is pulled down a distance of 5 inches from its rest position and then, oh my god, I can't even type them, released if the time for one oscillation is 3 seconds, write an equation that relates displacement d of the object from its rest position after time t in seconds. We assume no friction. All right, so let's look at this problem. Right away, we look at these numbers. And now it's pulled down. So therefore, it's going to be a cosine of omega t. That's what it's going to be. Amplitude is going to be -5 because if we draw cosine and if it started at the bottom, it's going to be negative. If it started at the top, then it's positive. So negative. What about a period? Period. The formula for the period is 2 pi over omega, and we know the period is 3. So omega equals 2 pi over 3. And we're done. So we just plug it in. D equals -5 cosine of 2 pi over 3t. So now let me give you another problem. D equals 25 cosine of 4t. And I'm gonna give you a set of questions. Okay. A. Describe the motion of the object okay. What is the maximum displacement from its resting position C. What is the time required for one oscillation? D. What is the frequency? Okay. So given that, the first problem is super easy. A is what? It's a simple harmonic motion. B. What is the maximum displacement? So the most it could go is 25. That's it. Absolute is 25 meters. 25. See, what is the time required for one oscillation? So period is 2 pi over omega. And then we get 2 pi over 4. So when we simplify it, it's pi over 2. So we want to know how long it will take to do the one period. What is the frequency? Frequency is, I give you that frequency formula, omega over 2 pi. In this case, omega is 4 over 2 pi, which is 2 over pi. That's it. So all the other stuff in the homework those are just extra credit. Once the semester ends, I'm gonna give you the boost you with the extra credit, and that's what they're used for. Okay. If you have any questions, anything like that, let me know.